What I've got mentioned here is fatigue and fatigue cracking. Fatigue cracking is one of the most common forms of failure in industry in anything that moves. Cars, aircraft, fatigue crack. A fatigue crack is, if I've got a stress razor, let's say that's a rotating shaft. Which way have I drawn that? That one. There. So there's our rotating shaft. If I've got a load pushing down on that, both sides, here that cracks in compression, getting closed. I'm just making a note for later as well. There that crack's getting closed. When I spin that shaft 180 degrees, I push that crack down the bottom. Now it's under tension. Spin it 180 degrees, under compression. Under tension, compression, tension, compression, tension, compression. These are the bolts that hold the wheels on your car. This is the drive shaft of your car. Crankshaft. Everything that's under force and rotating. Eventually, and if that crack tip is sharp enough, every time it spins around the bottom, it's going to be above yield strength and you're going to get a little bit of plastic deformation. That will eventually lead to the crack growing, 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 until it gets to a point, alright, I'll draw it in from underneath, because it does fail this way, growing, 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 until it gets to a point where the remaining metal can't hold the force anymore, and then you get a sudden and catastrophic failure. It does happen a lot, unfortunately, in aircraft that aren't maintained, involving loss of life. Could be an engine that goes, could be a propeller falling off, could be the wing root falling off, the entire wing falling off the plane, because when a plane's flying, the wings are up and down. And if you look at a plane head on, front on, there's the propeller. There's a stress razor there, isn't it? Big ones. Yeah? So, fatigue cracking. I've said it repeatedly, steel is weird. Every metal, except for steel, does this. There's the number of cycles, number of times you've flicked it up and down, and the critical stress to failure. Stress needed to fail. 1 or 2 cycles, it's up here. 1 million cycles, it's down there. Most metals do this. Gets to a point where even if 1 megapascal stress and 10 million cycles, it will fail. Steel, of course, is weird. This is why they still use steel in aircraft. Steel does that. Why? Because of the interstitial carbon atoms. Whenever a crack starts to develop, the carbon goes, oh, free space, goes and locks it still. Yeah, so steel behaves completely differently. Steel has a fatigue limit. So they still use steel a lot for the critical componentry, even though it weighs 5 times as much, or 3 times as much as aluminium. Weighs, density of titanium's 4 and a bit, density of steel's 8. So let's say almost twice as much, a little bit less than twice as much as titanium. Still gets used a lot because it's got the fatigue limit for critical applications.